that don't know me then, my name is Barry Cranford. I'm the founder of the LJC. I also run RecWorks, which is a tech recruitment company. So at RecWorks, we're all about trying to find ways that recruitment can be a force for good in the tech industry, beyond just getting people jobs. So what that means is that we're not just looking to help people get their next job and that's it, but we want to help people find careers that they really love or find a passion for what they do, and then help them go all in on it. So to give you a bit of a taste of what we do, we've built communities now of and news groups over 10,000 people. We've run over 800 learning focused events, and we've made over 3,000 mentor introductions. And we do it all for free, or at least free for you guys. So we're basically paid to find talent, developers usually, and then we take a chunk of that revenue and drive it into communities and initiatives and this kind of thing. So this year we've been doing something a bit different, and setting up what we're calling ladder groups, which is trying to bring together people that are on the same learning ladder. So aspiring speakers, what I'm talking to Sven about there. We've got 50 new people into speaking this year, and we're keen to keep pushing that and keep encouraging new speakers. We've got a lightning talks event tomorrow, actually. So if anybody's interested, then feel free to come along to that. Also run aspiring CTOs, and the latest group is aspiring principal engineers. So all really trying to help people climb the ladder within their career. If you're interested in any of that, then come and talk to me. Finding a mentor, becoming a principal, CTO, being the next Sven, whatever you want to be, then come and see me. Anyway, on to this evening. The event is functional reactive with Core JDK. So Sven is working as a developer advocate for Jfrog, and coding Java since 1996, and a regular speaker, as you can hear there, 200 events now, meetups and conferences worldwide, as well as contributing to IT periodicals and tech portals. So Sven, over to you.
Okay, thanks. So now the critical and the very challenging part is sharing my screen. So I will try it. So first I have to switch all this stuff again. So sharing my application. I think now you should be able to see my slides, right? So now everything from thing here is lost. So the only thing I'm not looking for is where's this chat window, because otherwise I can't see a chat here. So that's the only thing I'm always missing. Okay, so if there's any question, I will try to have a look at this chat window. I'm not good in doing more than one thing at the same time, but I will try to have a look there. And if there is a question and I'm able to read it at the right time, I will try to give immediately an answer. So don't be shy. In the end, I'm open for questions. So if you want to wait, so it's really up to you. If you want to write it down during the talk or just ask me after this one. So that's the first thing. Yeah, the thing we want to discuss today is something about functional reactive, and this in Core Java. Please, I never learned in other languages than Java, a little bit Kotlin, but please don't ask me why it's done different in I don't know what language. I don't know it. So one thing in the beginning, we are happy to have something that you can win. So here's something from Jfrog. We have here this bit.ly link, and if you're going there, there is this possibility to win this AirPods Pro. And yeah, well, just try it. And otherwise, have a look at jfrog.com/shownotes, and I think there will be the stuff as well. So it's a different URL just here. So the main thing, introduction, Core Java. It's the difference between object-oriented and functional programming in Java. This is one thing that is quite often a question, and I don't want to go in detail, and I don't want to go in detail why functional, what is a good thing at functional, and all this stuff. So I want to focus how to implement different things we know from the functional world, and I will just start here with some examples. So we all know that Java is an object-oriented language, and the question is at what point we are talking about this functional aspects or functional functional paradigm, whatever. So I think it's more or less a long time ago that we got, for example, these lambda expressions and this method handles. And if you're checking this one, whatever we are doing, we have different ways to write this syntactical, more or less the same stuff. But I think this is not the main thing doing something in a functional world. So just using a lambda expression doesn't mean that this is now functional. It's a way to describe it. It's a way to go to this functional world, but it's not functional. Functional means we have different aspects, different things we want to implement or to deal with. And then just to, well, I don't want to start a discussion with someone from the university that has a hardcore definition, what's functional, what's not, because I'm looking at it in a more practical way. So what it looks like for a regular developer in his daily life. So here, just a few examples of this different syntactical stuff. And I think the border between object-oriented and functional programming in Java is not 100% clear because it's an object-oriented language, but we can do with Java 8 and without Java 8. So pre-Java 8, we can do all this stuff, or a lot of this stuff, what I want to mention here. Just to have a short start here, one thing that we are using syntactically is a functional interface, just the basics here, just as a reminder. So we have this interface, we can mark it with a functional interface annotation, but it is just a functional interface if there's only one method that must be implemented. Have in mind that just with the default implementation, this is not counting as a to implement as a method that must be implemented. So you need at least one or maximum one definition of a method. So that's a functional interface so that we can start with this lambda expressions. We have this dealing or we have to deal with, for example, inheritance. And if you're going here to this inheritance part and just want to see why I want to go and have a look at this inheritance part with functional interfaces, because if you start designing an API, it should be clear what is the right place to push functional interfaces or constructions around this, and what is a good place to have this supporting utilities and all this stuff. For this, just a short example, we have an interface A, we have an interface C, and then we are playing around a little bit with inheritance, just as a small warm-up. For example, if you're going to interface A and we have the static method do more and a non-static method with the default implementation do something. So this is the definition. And we are going and writing here an interface B that is extending interface A, and we are writing the same method signature here with the default implementation. The question is what the winner, and so far we know that if I'm extending from this interface, more detailed or the last in the inheritance tree is a winning one. So the do something method from interface B, if I'm using this one, is the winning implementation. So you would see interface B as the system out print line. If I'm going to interface C and we are writing exactly the same method signature with a default implementation, and now we are bringing it in composition, like in class B implements interface A and C, then the compiler will complain because we have now the same method signature, we have two default implementations, and there is no inheritance tree we can use to decide which one is a more detailed implementation. So here's a compiler will just break and say, okay, you have to decide what is the implementation. Just have this in mind. So if you're going to functional means pushing abstraction to the limits. To the limits means you're mostly using more generic words. If you're using more generic words, it's most likely that you're colliding with other people that are using the same words. So be aware if you're building a big API with a bunch of classes that you have a good naming schema in your interface or interface hierarchy and all this stuff. One thing that is sometimes not really taken care of, the people are not really taking care of, is if you have this interface A and you have this static method do more, and you have something like a class A that's implementing this interface A, if you want to invoke this static method do more, you can't write class A dot do more. You have to push it to the interface A dot do more. That means if you're dealing with static methods and we need them later, then make sure that the place is in a good place so that you're not bleeding some internal API structures to the outside world just to use this or to give this one. So if you're creating this API, have in mind that you're choosing the right place for this static method. And why we want to have them, we will come a little bit later. So this is just a recap. So this inheritance, have in mind that you're choosing or you have to deal with default implementations and the static methods later on. What's not counting in here is what's coming from JDK 9 and upwards, these private methods. So these private methods are not counting for the functional interface stuff. And the good thing is, please do it if you have something higher than JDK 8, that you start splitting up the default implementation with private method implementations if you're not extracting it to other implementations, so that you're not going over composite, so that you don't have this big long default implementations. So that's it. And even here you can play around with the aspect of a functional interface. If you are inside a default implementation, you can use method signature sets outside so that you can just hook in with an implementation with this Lambda construction inside this default implementation as well. So it's something you can use to play around during the time you're designing stuff or you're extracting stuff so that you're not writing stuff again and again. So one thing that's going to the functional world is that you don't want to hold the value itself. You want to have something that is holding the value. Why? We have this, let's say this optional, and this optional will give you the possibility to hold this value and to ask and deal with this value. I will show why I don't like the full implementation of the optional and why we should work on this one. But here first, if you have this holder, this null value, it's just a way to get rid of null. So if you have no value, you have an empty optional. This is one thing that is going in the direction of a functional implementation or functional behavior, that you're not dealing with null, you're not throwing exceptions and all this stuff. And the optional is the first one. So you have an empty one, you have one with a dedicated type. And you can say maybe it has an implementation, but what's not so nice, over the time, the API of this optional is growing. So they are learning step by step what is missing. But for example, in JDK 8, they had just a method is present, but they hadn't the opposite. So you couldn't ask is absent. So this was missing. So you had always this indirection not is present, and this is not nice. With JDK 9, you got the stream that you can just say, okay, give me the stream. And if there's no value, you have a stream with 0 elements, and then you can just work on this empty stream. That's okay-ish. The next thing is that we need, if you have a value, I don't want to use this optional in this object-oriented way that I say, I have now this optional, I'm not dealing with null. Okay, first problem solved. But now I'm unpacking it, grabbing it out, doing something, and wrapping it back into this optional. So this is not the case, or not what we want to do if you're going to the optional world. So I want to place some instructions. The transformation and the value should be divided, the next part of this optional word. So just define the transformation and then provides a way to work with this transformation, to work with this value. And for example, here it says if present or else. So it's the first way to have something like a decision A or B. It's a final one, so it's maybe not really an if replacement, but it shows in which direction it is going. So extract everything that is transforming, extract the value itself, and then the function is you have a transformation, you're putting a value in, and you will get a value out. And this is more or less going through it. So this optional has some other stuff, but to invoke transformations, you have this map method. Here you can work with method references, with Lambda expressions. You can have just implementations on the fly here that's going in. But there are some things that are not nice with this optional. Here, for example, you have the possibility to throw an exception. I don't like it because throwing exceptions is not really what I'm doing or want to do in a functional world. I want to catch all exceptions, but I don't want to throw it. So with JDK 10, we have maybe this possibility, but why this is not really fulfilling all the needs for a functional world. The first thing is the optional itself is not symmetric. So it means you have sometimes a positive way, but you don't have the negative way. And this will lead to something that you can't really redirect. So you have this indirection with a negation to negate. This is something you don't want to have. If you're talking about functional, this fits perfectly to the reactive world, but everything on the optional is not asynchronously. It's always a blocking part. So later, if we want to deal with non-blocking elements, this is not working well. And from our point of view, it's not functional enough. And we can't change it because there is no inheritance. So it's a final class. So I can't just say I'm extending this optional and adding what's missing. And over the time, we saw that this API changed a lot. So if you're dealing now with JDK 8 and you know something is coming in JDK 10, maybe it would be nice if you have something as a drop-in replacement that already give you this method signature so that later, if you're switching from one JDK to the next one, you can switch back to the JDK implementation. So it's just you're implementing by yourself something, but it must be an easy drop-in replacement to get rid of your own implementation to switch back to your to the implementation from the JDK. So it must be easy to transform between optionals, so something from the JDK to your functional add-ons, because it would be worse if you have this whole complete different typing system and you're losing the benefits of the JDK itself. So this is not the goal. So what I want to have is something that's as near as possible as the JDK. And if the JDK evolves over time, and it is evolving fast, so that I can switch partially back to the JDK implementation to get rid of my own implementation, just to have less maintainable code and to be as near as possible at the JDK. So this is one thing. And have in mind, if yourself love the functional world, it could be that you're working in a team and not everybody is really happy with this functional approach. If you're designing an API to help you or to go to the functional world, it would be nice if it is in a way that people that don't like this functional world can even use it comfortable in the OO style world again. So that is not just pushing in one direction without any possibility to migrate between. So what we need, for example, is just a class. We can't inherit here, so we have to write something by our own. We can use optional as a default start, just copy paste and then start migrating, but it would be something like to optional and from optional so that you can switch easily between these two worlds. I think it's good to have something like a negative optional, but without losing type information and adding the information what happened. If I don't want to throw exceptions, I want to deal with this information. So I need the possibility to get this information. For example, you can define something like it is a failure, and maybe you have different method signatures. Here I'm just using the text, and then you will get the same optional back or the same result back with the same type. Here it's as example just an integer, but it's a failed one and will have the possibility to grab this information out, what is going wrong, so that you can deal with this, so that you can work with this one and not grabbing this one. So the symmetric one we already had as example, if absent, if present, just make it, and then we can combine it. This was an example from JDK 8, and now we have it. So now we could switch back to the original one. If you're creating your own method signatures, just try to imagine what would be the next in the optional so that you're using the same words and all this stuff. So if you have this one, this positive and negative way, what you could do, you can easily extend your method signatures with a word like async and switching inside this implementation to the reactive word with completely futures. I will show how to do this one, but in the main thing, what you could do is you would have the same behavior, the same method signatures. You're using the same lambda expressions, but you could decide if it is synchronously or asynchronously. This will be quite good, or it will be comfortable if you're later switching to non-blocking calls. You will have it. The next thing is you need something to combine something that is missing. We have this map phase in the optional, and we are just pushing a transformation in. So something that will grab the value, do something, pushing it back. But quite often I need something that is like the complete future. I have a value, I have this optional, and now I want to combine both without grabbing it outside. So you need a method signature with then combine, you're adding the next value, and then the transformation that is responsible for the transformation itself. And again, if you're doing this one, have in mind you can do it immediately asynchronously as well. We will have a look at this one. So combining with a value means that a value can be just a value like a string, but it could be a function as well. So talking about functions, quite often I see in the documentation or example that you have this transformation and the input is just a value, a string, an int, a class, or whatever. But the input of a function could be a function as well, because the transformation is creating the function you need. So with this in mind, what you could do is you can start composing functions based on very atomic functions. And this is what we want to go with a functional approach. We want to push abstraction to the limits, means don't write specialized functions here. Write generic functions and create specialized functions for your needs based on the generic main functions. And again, even this one could be done asynchronously. There is no limit here at this point that you're just doing this one. An example now, how to deal with exceptions. If you're going with exceptions, what we want to have is we have to deal with them. They are there. For example, if I have something like this, I have this integer parse int, I can push something in and just at runtime I see there's a number format exception. I think everybody of us saw it at least once. And the same is with a stream. If I'm consuming a stream and I want to convert a bunch of them, then I have this exception somewhere. And what I saw so often is that people start working like this. They start this map phase. Inside this map phase, they have this try catch. And then we have different things that are not nice. First of all, we have this try catch. And in every map phase, I have again this try catch. This is just crap. And the other thing is I'm pushing something back. Here it's a value 0. And this is not good because I'm using a value from all possible values as a non-valid value. So I have to get rid of this one. The first thing could be that we are saying, oh, I'm not dealing with null anymore, so I'm wrapping it in optional. And I saw that people start writing something like this. I'm creating something. If I have an exception, I'm wrapping it in empty exception, and then I'm pushing it out and filter this stuff out. This is not nice. This is definitely not nice. Even if you're going with JDK 9 or higher over the stream, it's too repetitive. And if you have different mapping phase, there's so many boilerplate codes you can just extract, but how to extract it? Because we want to have this one in a pure way that is so generic that you can just use it everywhere with every type, every time. The thing is, if you're looking here, what would be a way to extract this try catch block? Because this is what I want to get rid of. I know that I would wrap it in some holder, for example, if this is necessary, but I know that this try catch must be far away. I don't want to write it. Thinking about implementing something like a class is checked function. There's an input type, there's an output type. Now I have both types. I can write now my implementation and I have something like an apply with exception. This is a transformation and it's allowed to throw an exception. The next thing is I could use this one as a lambda expression or a method reference, what you see here below. Then you had a quite complex way of writing it, but how to do it. And if you're writing it in a generic way, what you will get with this. For example, this new checked function from string to int or whatever type would have this method to implement. Then you can use it in a way you want to do. But how to implement this checked function? The checked function is nothing else as a function from type T to an optional of R or a result of R. And then you can write exactly what you're writing always, this try catch and wrapping this stuff just to have this extracted. Now I have it extracted like a function I can use instead of a method I'm invoking. And then to make a function interface again, I'm just declaring this stuff I want to implement, this apply with exception. So this is done. Now I have a checked function, but with this, I have a lot of stuff done. And this is a key point of going functional, pushing abstractions to the limits. Checking this one, just with the definition, if I have a checked function, a generic check function, I have a checked consumer as well. Because a checked consumer of type T is nothing else as a checked function with a transformation from T to void. The next is I have a check executor. This is nothing else as a function from void to result of void. Why result of void? Because I want to know what's going wrong. So I'm just writing here this apply with exception and wrapping this one just to get this information out if I need the thing what was going wrong. It's the same with a checked supplier. A checked supplier is a supplier that will give you a result of T, and then you're doing exactly the same stuff. You have different possibilities to declare it. This is just the easiest way to just extract this stuff and to have not only a checked function, you have a checked supplier, executor, and so on and so on. After we have now this one, and we heard already this, what's the function or the stuff, let's dive in a little bit deeper in the function basic itself and what we can do with Java itself. A function itself is nothing else as a transformation from type A to type B. And then we have some type of declaration. But in the end, we have this transformation and we have an input type and an output type. So always we have a pair of input type and input value transform to output type and output value. If we start declaring now this, and this is what I'm seeing so often, people go into the function stuff and start to declaring functions, but they are declaring function at the wrong abstraction layer. For example, we have now this function A, B, and C. And then they're using it like this one. They're extracting it. Now it's a function. I can invoke it a few times. Yeah, it's just depending on the input type. It's nice, but it's not generic enough. It's just, it's a template. And then they're using it like apply, 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 and they're cascading this invocation like the optional world. This is not what we want to do. Here are two things that I don't like. First of all, the definition of a function and the abstraction limit or the abstraction level. And the next is how to use this one. So on both sides, we can do a lot. We have different ways to create functions based on other input levels. One is this compose, but compose is a bad thing in Java. Why? If you try to compose something, it will be in a way that these functions that you are delivering will be invoked before you are invoking yourself. This is here this return statement of the compose definition. That means you need this output type from this previous invoked function to see what is a type that is my input type. And the type system in Java is not good enough, so you can't write these gray lines like compose A and B, even if they are all the same type, because the typing system will just say it's not valid. You can't do it. So you have explicitly write this type information for every invocation. This is not nice. You want to get rid of this one. If you try this, what I'm showing now is just an example. It's nice if you have really too much time, and please never use it in production. Please, never. You can write something like a higher compose. If you just want to try to get rid of this definition of the type, and you start writing and playing around with this stuff, it could be that you're coming to this point. There's something what you can learn out of it, but it's not usable. This higher compose means that at every time you need the type information so that you can start composing these functions. And here what I have a function that will transform a function from int to a function that is possible to transform a function from int to a function from int to int. Well, but what we are learning here is it's way better to describe what you want to have so that it will be created instead of writing down what you need. So just to show it is working, but we are not winning something. First of all, this is not scalable. This annotation or this way to describe if you need the next level or a higher order function, this is just not really working. It's not scaling. And the other thing is we are not getting rid of this typing information because we have to declare them, every single one, but just in a different way. And here it's just, I have to declare it during the time I'm invoking this method. So we are not winning something that is just not good. So, so don't use this in production. It's just to learn a little bit about the typing system. So the good way in Java to compose or to create a higher or to concat function is to use the and then, because then you're doing it in the reverse order. So you're invoking first yourself, then you have the output type, and then you can push it to the function you have. So it's just the other way to implement it. You have to rewrite your stuff, make sure that you are writing semantic equal. But going back to this example we had, what should we do? What I wanted to have is something like a compose A, B, C, and then implying, because I have different transformations. I want to cascade them and I want to invoke it. What we can have is a function with and then, and then, and then. Then with the typing system, we are coming to this point. We just have to think about the semantic equal version out of it. But first of all, how to get an instance of a function? Because if I want to invoke and then I need an instance of a function, what is the right place to get it and to declare it? The first could be that you're using static methods in interfaces, because then with static imports, you can just have a very compact short thing and there's no state, so you don't need attributes and all this stuff. So just have this function A, function B, function C. With this one, we can write now something like function A and then function B and then function C. It is compact, it is dividing every single step, but it's not generic enough. It's just not generic enough. Why? If you're looking at function A, B, and C, the most stuff we are doing here is repetitive. We are writing again and again the same stuff. The only thing that is changing is the value 2, 10, and 5. And so we are coming to this higher order functions, or to functions, how to create them. If you want to go functional, you have to think, what is a generic way to express your transformation? And the generic way is, you're not defining an adder A, an adder B, an adder C. What you need is a function that will give you an adder based on the input value, because this is the only change between all this one. So what you're writing is now a function that is giving you, based on an input value, a return, a function, instance of a function. So now I have this generic way of describing the function. I'm supporting the whole range. So if I need something different, something like plus 15, I'm just invoking this one. And I'm extracting the values as much as possible. And with this, I can right now apply, create the next instance, and so on. And if you're thinking about this one from static definitions to composing these functions, just open your mind that you can do it in all dimensions. This is a generic approach that is scalable, whatever complexity you need. So the adder itself is just now the static function that will give you as return instance an integer that will be transformed to a function. Having this in mind, a function can be transformed to a function, and so on. So this is a way to build this, this ecosystem of functions you want to have, and you can create a very compact way of describing your stuff. Quite often, if you're coming from this object-oriented world and you want to start with extracting stuff, the most ways I see that people start with extract method and all this stuff. If you're doing this one to go to the functional world, it will go in the wrong direction. For example, here, you have these two implementations, this stream of this first value and then stream filtered of the second value. And the only difference is these two input values. So how to extract it so that we are at least going in the direction of a functional world. The first, if you would say, I'm extracting this print line, this is okay, this is a consumer, you can define it somewhere, you can extract it in a static function or whatever you need as a consumer, that's okay. But then if you want to extract this predicate with extract, it will lead you to something that's not scaling because the input value is a final. This I is a final string. So you're not winning something, you're losing stuff because you're just writing again and again the same stuff. So extracting with this extract method is not the right approach to find the potential for functional elements you can extract. Again, what you need, describe what you want to achieve, not write down what you need. What you need is you need a function that based on a string will give you a predicate. Because then you get rid of this final stuff and you're just describing the transformation. I have an input and it must lead to a predicate. And if you're doing this one, you're extracting exactly this one, and then you have more or less the same source code and you're just invoking this part with different invocations of this function predicate. That's it. So now you start extracting the transformation, not transformation bound to a value. And this is quite often done by object-oriented people, that they are not really decoupling the value and the transformation. But we're now going a little bit higher. People say, oh, I need more than one input value. But if you're looking at the functional bugs, what you see is that people say a function is just a transformation from one input value to one output value, whatever it is. It could be a function to a function to a value to a function, whatever. But one in, one out. What's a bifunction? What's a trifunction? And how to deal with this. For example, I have this bifunction here. It will lead me from A and B to a return type R. And this means I want to transform it in something like I have a function that based on the first value will give me the function for the second invocation, and then I'm invoking the second one. So what I have now is that I'm reducing this bifunction to a function itself, because one input value, one output value. How to do this one? I'm writing down here what's exactly what you need. You have to transform this bifunction to exactly this function that will give you, based on an input value, a function that will give you on the second input value the final result. It's an indirection. If you are working a little bit with this, then you see that you can do it in both ways. You can go for a bifunction to a correlate function, and from a correlate function back to a bifunction. So you can transform in both ways. At this point, you are able to grab some JDK implementations that's using bifunctions, transform it to correlate functions, working with this, and transform it back to give it to the other API back. So make sure that your typing system and your function system is interchangeable in both ways, not only in one way. Some kinds of some open source projects are just supporting the transformation from external to internal, but not back. This is not nice. You need both ways. So if you're able to transform a bifunction to a correlate function, what we are doing with the try function. Because if you're solving it for bifunction, it must be the same way to solve it for try function, quad function, whatever function. And with this, if I have this one, I can transform every object-oriented method with a bunch of methods to a corresponding function and correlate function. A try function is just the same. We have now 3 input types and 1 return type. And I'm doing this one exactly in the same order I've done it with the bifunction. I'm just adding one more dimension. A function will give me a function that is based on the input value, give me a function that is transforming the last type to the last one. So I'm just adding the next dimension. So if I understood this one, and again, I can transform to a try function and back from a try function. So I can query and unquery in both, and I can do it with all dimensions I have. And this is fantastic because now I can transform everything in both directions. And there's just a few lines of code. We're writing it once because this is so generic that you can use it for every type. This is a way. If you see something else than this generics inside this definition, it's wrong. So you have to reduce it to the generics, and then you're on a good way. The next thing is, after we are able to transform now these methods to bifunction, trifunction, so these higher order functions, and then to these correlate functions, the next thing is that in a functional way, people say, if I'm invoking a method 2 times with the same input value, I'm expecting the same output value. So the first thing would be you are calculating the same. An int will give you the same result int. Car input will give you a whatever instance. You're invoking it both. Now we have the second instance of this class. They have the same values, but they are not the same entity. So for this, what you need is memoizing. Memoizing is a powerful thing, even if you're working with legacy code. And this is just nice. This memoizer, what we need to memoize means that I start remembering what I have done before. And if I will get the same input value, I'm just giving the same instance back. It's some kind of caching. So this memoizing you can implement here. It's a very trivial implementation, just based on a concurrent hash map, for example. And then you have here this possibility to transform a function to a memoized function. So every function you're doing has nothing to do that it's able to memorize. The memoizing itself is a behavior that must be implemented generic, and then every function can have or can wrapped or can be modified to be a memoized function. Don't write this stuff in every function. So the generic part is you will get an input, a function, and what you're doing is just you're wrapping this compute if absent around this method invocation or this function invocation. And with this one, you can give back exactly this memoized function. So you're putting in the function, you will get exactly this function out again, but it's now able to memorize. What you can do with this one. What you are doing here is, for example, we have this by function. If I have this by function, I can query it. If I can query it, I can memorize it on every dimension. So if I have this querying for every dimension, and I have for one dimension the memoizing, I can now start building a multi-dimensional memoizing, because I'm invoking this memoizing on every dimension of this queried function. And now I have a multi-dimensional caching on a multi-dimensional function. So this is quite cool, and you can decide on every level if you want to have it or not, and then just use this one. And in the end, you can use this queried memoized function and transform it back in a pure by function. So from outside, it will look like a by function, but inside you're using these mechanisms, but you're building it on these tiny bricks. And there are a few things you could do here. So the way to do it is just here, so that you're, here's just an example of how to do it step by step. So create a memoize back to the by function is this transformation from A to B, and how it could look like. For example, here this memoize, then you're pushing this lambda expression in and will get this by function back. But inside you have the transformation forward, memoizing backward, and then that's done. So from outside, it really looks like a cool by function. And this is a generic behavior you can add now to every single function. But you can do a way more with this, because if you have, this is an example from by function, and then you can do the same stuff with try function. It's just a different way of writing it down. So if you have done it for one dimension, and you can do it for many dimensions. The same then with try functions and so on. You will get the slides, and I have detailed talks on YouTube on this one, so you can follow up with this stuff if you really want to code it, and I will give you the GitHub link with the implementations, so you can just try it out and grab the source code and run this stuff if you want. But with memoizing, you can do something cool. For example, we have this legacy class, and this legacy class is just a class you are not able to touch, because third-party class, it's legacy code, it's owned by someone else, whatever. And there is this method called doWorkA, two input values and a string output value. Some stuff, old stuff, you can't touch, whatever, impossible. But you're creating now this function interface stuff, and you want to have this, and you have some fancy new implementations, and you have this method, for example, this do new stuff. You want to have a by function as input, and you consuming this stuff and whatever. So you have your API you're creating. What you now can do is that you can combine these two worlds, this pure object-oriented with functions or invocation of this one. Why? Check out the main method here. I'm creating this legacy class, and this legacy class is the implementation I'm not changing. But what I want to do, I want to add some generic behavior. There's the next example. I think, yeah, what I want to show. What you could do is here that you're extracting from this instance the method reference from do work A, but not from the class, from this instance, explicit from this instance, because this one is a bifunction. Why? This method reference is nothing else as int in, string out. It's a bifunction, int to string. If this is a bifunction, I can curry it. If I can curry it, I can add memoizing. Wow, what can I do with this? What I could do is I can use this legacy instance. I'm not touching it. I'm grabbing this method reference out. I'm adding the functionality of memoizing, and now I have partially caching on a legacy implementation I'm not even touching. And if I'm giving back my legacy class, this instance, it's exactly the same old behavior. No memoizing, nothing. That's it. And I can do it in both directions. So that is something you can do. You can extract very generic behavior. And with this approach, you can add this behavior to even to legacy code without changing this code and touching it. Functions means that you're going to different directions. For example, we have this switch, we have this if then else, we have this construct here with this thing here with this asking sign. So whatever you're using, it's not nice. What we need is something that is more functional, because I don't want to add more if then else or this case blocks and so on. What I can do here is that you think about you want to have this pattern matching in a way that you have some condition, and then based on the condition, some reaction. And this means you need something like a supplier for Boolean that will say yes or no, and then you need a supplier for the result. This is what you need. Because based on this, what you could do is you can create now a linear list of decisions based on whatever complex constructions that will deliver true or false, and then some code that will be invoked. It looks like that you have this is matching and this result function. And this matching is just, you're going through a bunch of these cases. This is yes or no, and what should be invoked if yes. And if you have the first one that say yes, you're just invoking the second part of it. And then you just break. So here at this point, you just stop with execution. So this is one way how you can get rid of if then else, switch blocks and all this stuff and just have this one. How it looks like in code is you have, for example, this match, then you're defining everything. For example, if you have value A, it's true. If you have value B, it's true. Or if you have value C or whatever. And then on the right side, the execution parts that should be done and the default. If nothing happened, what is the default that should be done? It could be a positive or negative result. And then you can work with this. If you're using static imports, you have a quite compact definition of this. You can rename the wording, but it's always the same. You have this default expression and an unlimited amount of special expressions, and it's always the same. A supplier that will say yes or no, and then the piece of code that should be invoked. And then you have something like pattern matching, and you can cascade it and so on. So that's one. So a complex if then else tree can be reduced to a linear list of decisions. Streams, I don't want to go in all details with streams, but what I want to say is a stream is normally active after creation. That is not nice. We want to define streams without invoking it, and we want to create streams on the fly. And if you're going to the functional word, it's just thinking about, we have a function that is building based on input value, a stream of type whatever. And if you're doing exactly the same, you can start now building streams based on the functional composition. And if you have this one, you're just invoking it, because the last invocation of this function will create the stream, and only this one is then active and will be executed. So even the composition for the streams world can be done in functions. If you want to compose this one now with a reactive world, after we have all this extraction done, is a question, if we have this function part, that is just a transformation and the value is extracted, the good thing is that it matches perfectly to the reactive world, and even the JDK will give you a lot of possibilities here inside. And what is the reactive words. The easiest would be just an observer. Here's just an implementation on this concurrent hash map. You're adding something, you're removing something, and then you're sending an event. So it's just an observer pattern. I don't want to go in detail here for the observer pattern. But if you have this one, you can start building registries. Then you can have this just register somewhere, I'm listening on something, and so on. And think about building, so register and unregister this stuff. And we are just dealing with a concurrent hash map. And the most thing is you have some key to identify, now I should be invoked. And then this piece or this function, this transformation that's just based on the input value, the event value, that is then the part here. So it's quite easy to combine both, but we want to have it a little bit more convenient because we have a very powerful construction inside this JDK. We don't need to build this observer. Only with this few lines of code, you have the decoupling between components and you can shake events left and right. So this is quite neat, but I want to go now to this completely future because there we have a full thing that is really, really great. For example, this complete future, I don't know who played with this. I think everybody had at least a few minutes to look at it, but it's not a process, not a thread, not a fiber. It's a complete, it's a fiber, and we have to deal with this completely states. So it's a very lightweight thing, and you should deal with atomic operations to compose it. To create it, it's just you can say that you have some executor pool, where the dedicated resource pool where you're pushing your work in. It will be worked inside, and then you can wait until result is there. That's just a very broad, high-level view. To get access to it, you have this complete future supply asynchronously, and what you're combining is the pool where the work should be done and the transformation you want to have done. So transformation means it's perfect for functions and compositions of functions, and you can divide here the value, the workload, and the transformation. And the good thing is then you have this then accept asynchronously. So here is this cascading of asynchronously events, and then you can join and shut down or whatever, so you're waiting for it. But what you can do with this, if you want to, let's go here. If you want to have something like this, you have a value A and a value B, and there's an operation, a function that needs both input values. And then there's a value C, and based on the first result, you want to operate the second one, but you have no clue if A, B, or C is the first one that's coming, and so on. It would be a perfect place for dealing with complete futures, because you can compose all this stuff. If you're doing this one, the first thing is that you can create all these independent complete futures if you want, and then you can start combining them. And you see this combination is mostly this step before plus the transformation. So all we learn from the function world, we can add here. And in the end, we are building some kind of complete future. And the main thing is that if you now start writing it more and more abstract and with static imports, we have a very compact way of combining this stuff. But in the end, we have the same. So if I'm starting this complete future, I have to think at what time this is running. But saying here that if I want to extract this transformation again with the static methods in interfaces to create this instance, then I can write this stuff together. But if I'm looking at this piece of code, so most stuff is just again and again the same stuff. So then combine asynchronously, then supply this one. The only thing what I want to have is the instance of a function and maybe a pool if it is necessary. If I want to say everything should be done in one pool, I just want to add a bunch of functions. And in the end, I want a loosely coupled construction or a loosely coupled tree of actions, and I want to wait. So this piece of code is just too repetitive. There are so many, it's repeating itself again and again. So how you can extract it? Have in mind, I want to have this one here. So, and now we're coming back to where Java is coming from. Java is an object-oriented world. And the design pattern we learned during this time are not bad. And the good thing with Java is you don't have to decide to go fully functional or fully object-oriented. You can grab the good of both worlds, the best of both worlds. For example, a couple of futures active after creation. I want to get rid of this one. I don't want to start and then creating all this stuff. Maybe I want to create this whole tree as a template and then invoking it at a dedicated point of time, because I'm waiting for user interaction, I'm waiting for some data, I want to have some decisions done. So what I need here is, again, I need a function that is able to create a complete future based on input values. And even this can be correct and incorrect and so on. So even here, if you describe how to get to this complete future, it's better than to write down your complete future, because then you can reuse this function. You can do all the stuff we learned about functions, just you can combine it with complete future with the reactive world as well. And on the other side, if I want to get rid of this first one that I marked with manual, this very repeating piece of code, I can think about the builder pattern, for example. So combine what you learned in the object-oriented world with the functional world, because here what you can do is just, if you want to have a function, you can do it like this, that you say, okay, I'm defining step 1, step 2, step 3, this is just a function. I want to combine them asynchronously. And if this is done, please give me the result. So activate and then start with this after I invoke the apply. So what we are doing here is we are extracting the transformation, the creation definition from invoking, really invoking and starting the work. So with this approach, we can divide the definition, the composition of this one, and the actual usage and resource allocation. And this will give you the freedom that you can work very, very abstract on this one and create some stuff. This is just a builder pattern. It's a lot of code. It's bad. It's good if you're just looking at the source code on GitHub. I will give you the URL. But the main thing is it is a builder pattern, nothing more. It's just a builder pattern. So if you want to have a look at this one, just go to this functional reactive repository I have here, or just ping me on Twitter or whatever. I have additional stuff. I'm recording step by step this functional reactive with Core Java stuff on my YouTube channel. So if you want to have different other topics, I would be happy to have more subscribers. So since COVID, I'm not traveling, I'm creating YouTube videos. So I would be happy to have more subscribers. So have a look here. I have this one in German as well. So if there's someone as a German speaker, just go to my German channel, and that's it so far. So first of all, any questions? Now it would be the right time to ask. And we are, wow, damn, exactly 1 minute. Silence.
Hello.
Yes.
I wanted to ask, first of all, thank you for the interesting lecture. I wanted to ask about the precise definition of carrying and anchoring. It appears to me that it takes binary function and splits it into a value and a unary function, but is it the true definition?
Well, I'm not working at a university, so I'm not sure if it is a pure way of doing functional. So this first, so I'm not saying this is the only definition. So I'm going a practical approach. A practical approach is I have this bifunction, trifunction, whatever functions. The first thing is in the JDK, we have a bifunction, we don't have a trifunction, whatever. So if you want to map methods with more than one input value to functions, it could be the first way to extract this one as a stateless function with a bunch of values that you need for the invocation. But if you want to extract this one in a more generic way, to have the possibility to extract really the core definitions you want to have, you need to reduce this to pure functions. A pure function is one input value, one output value. So 2 input values to 1 output value will be transformed in a cascaded step of invocations, a function that will give you just a function, and the last function will give you the value. I can go back to this one. It's memoizing curry here. So this one, okay? So it is, so instead of providing it's the first time 2 values and then calculating everything, you can split it up. And this means you are able not only to invoke it one after another, you can just decouple this invocation method. So if you have just one value, you can do the first step. You can create the first transformation. And then a few minutes later, if you have the second value, you can go with the second value, because now you have everything that you need to invoke, or to, not to invoke, to get the final transformation. And even then, the lifecycle is in a way that even then the invocation of this transformation is even later. So you're decoupling the time of invocations. So you have a way to have different times to invoke. You have the freedom to extract single transformations. And it must be in a way that's completely generic, so that you're not bound to a type itself. So it must be, that's always the same. It must be done with generics. Otherwise, you're not on the last step. Okay? So, and if you're able to transform a by function to a current function, then at this point, if you solve this challenge, then you can try to solve it for the next level, for a try function to a current function. And if you have this done, you broke the nut. So now it's open. Now you can do it for as many as values you want to have. And now you can transform every legacy method signature to a function, to a current function. And then this means you broke this method with a bunch of input values to a series of stateless single transformations. So, and this is a perfect approach to really to go to the generics version of your transformation itself. You break it really in atomic parts. So this is maybe a very theoretical point of view on this one, but it will give you the possibility to combine legacy code with functional immediately, because you just say, you have 5 input values. Okay, I hold this signature, but inside this legacy code, I'm switching now to my functional approach. You're transforming to a functional approach. You're going back, and you're going back to the legacy world. So I have always in mind, so I'm since a long time, I was just working at UN, WorldBank, whatever, space, military defense, it's all these huge legacy projects. And you can't say, I'm just creating my own type system and everybody has to follow. That's not possible. So you have to find a way to cooperate with this existing stuff. And this is one step that's going. And then you can start thinking just of, okay, I need caching. First, I implement caching for one single transformation. If I have caching for one transformation, and I have extracted the way to transform transformations, now I can combine this. And if you have done it once, you can do it with so many other aspects as well. It's always the same behavior. It's always the same way to go. Could I give you an answer? I hope, at least, half.
Yeah, thank you for the detailed explanation. I guess here the keyword is stateless atomic operations,
Yeah.
which you can cache, and you can then transfer the execution of the program to like to if you presented as a tree, and then you can decouple this tree
Yes.
as far as I understood. And you were talking about fibers.
Yeah, or thinking about Hazelcast. You know Hazelcast?
Yeah,
this distributed executor.
Yes.
This is perfect. If you're able to transform it to functions, then you can push it to a distributed executor, because you're just pushing the transformation, and at some other point you're pushing the data, or the data is inside the distributed map, and you're just pushing the transformation. So if you're going this way, then it's a good way to distribute, to work independently, concurrently, and all this stuff.
Yeah, thank you very much.
Okay.
Any other questions?
I have a question.
Yeah, sure.
I'm going back to the basics. When you write a generic method in Java, right, and that returns a current function, the type parameter information next to static, right, that has to be in the perfect order, isn't it? So would you throw some light on there? I mean, how the order should be maintained? I mean, like you have, this one is simple one, like it's taking A and B as input and returning R as input, output. And when you have more than 3 type parameters, then I think the way we define declare the functions in the current function, the order is important, like this one, yes.
Mm.
So how the order should be followed, you know, I mean.
Well, the main thing is what you shouldn't. So if you're writing this transformation, don't think if you have an int and string and then int again or whatever. So the order. So if you have a legacy method int string, but you want to have it in your functions for whatever reason, string int, this is just the layer between the data's coming in and then you're mixing the invocation of this current function. This is something that you can do. It's just the shuffling of types. The main thing here is that the definition of currying is completely independent of the type itself. But the thing is, if you have A, B, C, you will have a function A that will give a function B that will give a function C. So there's no change in the order. This is fixed. So if your question target this one, so if you declare int string, it will be int string in the invocation. If you want to have a different, then you have to declare it string int or int string or whatever. Okay. So inside this curry process, the type order is strict, but decide in which order you want to have it. So you can invoke it in a way that's convenient for you.
Okay.
Sorry, can I just add a little bit to this? So I think this notion of currying came from a certain type of categories where associativity also holds. So basically you have currying, which is exactly what Sven told us is, but at the same time you have associativity, which actually means it doesn't really matter where you put the brackets in this sort of apply kind of. I don't know if it makes much sense. So the order, you know, whether you do, you know, whether you apply a, and then you could, instead of having the dividing the function and first type being A and then the second time being function B, and then a function from B to C, function of C and R, you could put function and have the first type being from A to B, and that's where it really comes from. Basically, it relies on associativity, basically. You know.
Okay.
Well, if you have any questions, the good thing is just write down what you have in mind. So as a code example, and let's connect after this meeting, just and send it via mail or whatever. Maybe I can help there, so that you give really an example of code. So maybe so.
Yeah, I'll follow you on Twitter, and I have a question. I have a code sample which I don't have right now, but that's where I had some questions about. I couldn't find the answer. Like when I, just I read it in one of the books that the order is important, and I saw that, when I change the order, it just compiler gives an error. I have to strictly follow that order, and then I couldn't map like why is it applying that order.
So inside this definition, of curry try function, the order matters because the final function is typed in this order. But how to invoke this one is completely independent. So, but maybe so let's wrap it like a pseudocode, and then let's discuss it on your example. Maybe I'm understanding something wrong or so. Let's just formulate an example, and let's connect on Twitter or whatever and discuss it there. But I'm sure that we will find an answer together. It's this for sure.
Thanks.
Okay, cool.
Thanks.
Are there any other questions for Sven? Okay. Well,
so otherwise, Please subscribe my YouTube channel. I'm working hard for it. I'm talking in the forest about stuff. I need YouTube followers.
He does some really amazing shots. If trust me, I've seen a lot of them. Thank you so much, Sven. I checked with Barry. Barry left a little bit early, but my name is Ari Waller, and he asked me to co-host tonight, and I am the Meetup event manager for Jfrog. So wanted to let you know that we have a raffle associated with where you can find Sven's slides and other documentation for this talk. I'm going to share my screen really quick if you'd like to join, because what we have is actually if you can see my slide, hopefully in just a second, you will anyway. We are going to be giving away a pair of Apple AirPods to a lucky winner. And the way that works is we will contact the winner within a couple of within 2 business days. And a winner will be selected, and we will contact it and share with the entire community. But there's a QR code if you want to scan that. And I also dropped the link inside the chat as well. So hope everyone can take part in that. You know, Jfrog, even Sven spoke a lot about Java, and our flagship product Artifactory is written in Java. But we also offer a lot of free DevOps tools to the community as well for you to try and get your hands on. We have a free platform for developers that I dropped a link in there as well if you wanted to get your hands dirty with a little bit of DevOps too. So thank you again for coming, and Sven is definitely reachable on Twitter, and feel free to ask any questions. And also, anyone that enters the AirPods contest, by the way, is going to get a free Jfrog t-shirt, just so you know. That's why the address is asked for. We're not going to send you anything else, just the t-shirt if just for entering for the AirPods. So I just want to spread a little bit of community cheer during this quarantine time that different parts of the world are facing and stuff like that. So without any further ado, if anyone has any final questions, we'll leave it open for just another minute. But if not, look forward to seeing you back at the next meetup.
Okay. Then thank you from my side as well. See you soon. Okay, bye.
Bye-bye.